This is the second of the videos of three videos. So in this video, I want to demonstrate how we can debug the code that we write. So for instance, just for demo purposes, I did create a string.h file. Now, this is a very simple one. And what it takes is to take a valid string and return the reverse of the string. So I want to reverse the string. So if you give a string, you just reverse the string. And that's what it's supposed to do. And in this file, this is called string.a.c. I actually implemented this reverse function. And notice that I have string.a.h included. So it knows string reverse exists. And so the way I try to reverse it is that I'm going to use the string length from the string.h class just to get the length of the string. So I would go from 0 to less than n length, which is given here. I++, I will copy temp equals s of I. So essentially what I'm trying to do is in this logic is to just shift the characters. Now, some of you may see the problems already in this code, but I'm just going to assume that you have not noticed the obvious errors in this code. So the way I try to reverse it by just swapping characters, first character with the last one, and so on. So let's see how this is going to work. So in order to test that, I need to go here. Let's take another window here. Yep, let's take this one here. So what I need to do is to compile this code. So I have a special function that we created, special file that we created, teststring demo.c. So this is like your teststring thing, but it just has only a few functions to test your reverse. So I'm just going to compile my code here with the teststring demo.c and create an executable called teststring A. And so it worked fine. So at this point, I want to show you how teststring demo.c looks like. This is just a customization of the teststring function that you are given. It's specifically designed to test the reverse, and that's the only thing it's going to do. So it does boundary test, which means that if you take an array, or if you take a string, which is in fact, although it has size 2 here, because of the null character here, this is going to be a string of length 0. And if you reverse a string of length 0, you should get a string of length 0. So I do the string compare, result 1 and result 2, and then assure that those results match. So the second test, it's the same thing. I have given just an empty string, reverse it, test it. Statement test, this says that let's give an array, but it ends with the null character here, so it's really the string root. You reverse it, and if you reverse root, you should get HTUR, and I'm comparing to see if they are the same. So if my string function is working, string reverse is working, I should get something like that. So having seen the teststring demo, what it's testing, let's just run our test. So for example, I'm going to create the executable teststring A, and then I'm going to run this, and notice that it test at line 99 failed. So what I need to do is now use Emacs to figure this out. In order to use Emacs, I'm going to use one of these windows here. Okay, that's the window there. I'm going to, let me use this window here. All right, so I'm going to start Emacs and then GDB debugging session to find out what's going on with this. So let's just say the way I'm going to do that is just by typing Emacs. And so I didn't type the file name, so it just gives you Emacs. If you press escape and X character, you're going to get a prompt here. Right there, you're going to type GDB. If you press enter, you'll see that the executable test string A is what it's going to do. Now note that I used the G flag to make sure that this executable is ready for the debugger. So let's just start this. Now at this point, what I like to do is to break at my function. So I'm just going to say break at the string reverse, because I want to know what's going on. Why did this fail? So let's do that. So it sets a breakpoint. Now I'm going to start running the code. If we just type run or R, it's going to do that. So notice the nice thing about GDB and Emacs is that when you start executing the code, when you try to debug the code, you're actually going to see where you are. So right now you're here. So let's just say that I want to know, so I entered this function with some s. So I must have the value of s. So let's just say I'm going to say print s. So it looks like s is the null character. Perhaps it was taking this, doing this test here. So it's this null character. And then I can type next or end to go to the next line. Notice that it moved to the next line. You type end again, move to the next line. So at this point, I should be able to print one of these variables, like for example, length or len. So that's 0. So that is fine because I think we're dealing with the empty string. And then I say next and next. So that's the end of the function. And maybe I want to print s again before I return. It seems still empty. It didn't do anything mostly because string length must be 0, and therefore it didn't even go into this loop. So we say next. Now it went to the test demo. So it's somewhere here now in this file. So notice that it's doing the boundary test. It's doing the boundary test, and it has come to this line. And if I say next, 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 so that's fine. I think I passed the boundary test, so I'm not going to worry about that. So let's just say next. So it's going back to the next call of the reverse function. It's probably here. So next, next, next. They're both empty, so probably nothing's going to happen here. All right, now we go to, so we are still at the null test. So we're saying next, next. But I passed those tests, so I can just skip through those. All right, now I'm getting into the real test here. So right now I'm going to test this one. So let's do n. So okay. So at this point, you have read this variable. So let's just make sure that we know what's in there. Print AC src. Did the computer correctly put in there? So it seems right. Root, that's there, and the null character. Now, what I'm going to do is I'm going to say next. Okay, so it went to the function because remember, it's now going to the reverse function, and it's at I equals 0. So at this point, I can say, what is S? Because S must have been AC. So it must be root. So if I print S, yeah, it seems like it passed the variable correctly to the function. So I'm going to say next. All right, at this point, I should be 0. I can double check that. All right, so I'm going to say next. At this point, I'm going to print length. Now, length should be 4 because this is a string of size length 4. All right, although the array has more elements because of the null character, the size should be 4. So I'm going to say print length. Okay, that's correct. And then I'm going to say next. So at this point, I enter the loop. So length is 4. So temp is si. I'm going to say next. All right, so let's print temp. All right, so that's R. So that's good. That's the first character and so on. So let's do a few times the next and the next. So this is the second iteration. So if you say print I, you'll see that the I equals 1. And next, next. Okay, so this is the third iteration, print I. Okay, so that's, it's the third iteration with the index 2. This. And going back again. At this point, I can say print I. So I equals 3. Next. Okay, at this point, I must be, okay, so it doesn't enter I, right? So before we return S, let's take a look at what S is. So let's take a look at this S. Oh, S is the null character. Okay, so now I want to figure out why I got the null character when I was trying to reverse root. So what I did was to go back to the test string demo, and I commented out the boundary test, which I pass anyway, so I don't need to worry about them. Okay, and then I also created the debugging, the executable code for testing this. So as before, I'm going to start Emacs with GDB session. So I'm just trying to type Emacs, and it starts Emacs, and then I press escape X, which gives me a prompt here, and I type GDB, and when I press enter, it should find the only executable in the folder. I can change that name if I don't want it, if I want something else. So I press that, so I'm ready to go now. So I'm just going to say break at the string reverse function. All right, so I have the breakpoint, so I'm just going to say run now. So as we saw before, the nice thing about this is that you have two windows, one for debugging and one for the code, and it shows where the code is, which line of the code is running. So at this point, as we saw before, we entered the code. We're trying to execute this from the demo or test script. And we call string reverse with AC source. So this means I pass this array to S. So this means if I print S, I should see root, which is good. So this is the content, and this is where the address of the first element is. And then if I say next, goes into the next one, I should be 0 now. When I say next, it must have computed length. So if I want to double check, I can just say print length, that's 4. So I go to next. So let's go through one iteration of the loop. So I think if I print I, you will see that it's I equals 0. So I'm going through the first iteration of the loop. Okay, so I'm here. All right, so I completed one iteration of the loop. So let's look at the S right now. Oh, so I see something here. What happened was it put R, which was here, into this location. So it seems like it copied S of 0, which is R, and then it says S of I equals, which is S of 0 equals S of length minus I minus 1. So it took whatever was here, edge, and put it here. So this edge here came here, and then it says S of length minus I equals temp. So something is wrong. So I should have R here. So it is clear if you look at it. The code shows that this should have been length minus I minus 1. So we can fix that. So let's go ahead and do it. We're just going to change this to length minus I minus 1. All right, so I went ahead and changed this to as length minus I minus 1 temp. And I make sure I saved it. Then I'm going to recompile this and then go back to the Emacs with GDB. escape x.gdb, and I get this, and I'm going to say break with just a b, string reverse. Yeah. Okay, just say run. It's there. And I'm just going to go through this. Next. Okay, so I'm at the function now. Most likely my I is equal to 0. I'm going through the first iteration. Next. Okay. I think I'm into the second iteration. So at this point, I will see what the value of S is. Oh, that did the right thing. So let's go through this. So I think I'm at the second iteration with I equals 1. So type next and next. So I finish the second iteration. So at this point, let's take a look at the S. So I did switch these two, and also it did switch U and T, which is good, right? So I did that, and then I say next and next. So now I have, let's see if we look at the print I, I'm doing the second iteration, and next and next. So I'm back, and let's print S again. Oh, so this is not good news, because what happened now is that it went back to the old one. So something is wrong again. Now, if you closely look at the code, you will see that I should have stopped at length over 2, not go all the way to the length. So what this code does is it actually reverses the characters, but it does it twice, and therefore it goes back to the original string. So if you change this to length over 2, you would be able to get this thing working. Okay, so now that we did an array implementation of string reverse, let's just do a point implementation. The difference is that I'm not going to use any bracket notation. I'm going to think about the string as in terms of pointers, access, traversing the string with pointers. So what we know is the following. I'm going to call it left pointer. So left pointer is pointing to some leftmost character in the string. So I'm going to initialize that to S, because the leftmost character in the string is really the beginning of the string, or the starting address of the string. If you want to be more specific, you can just say, I want to take the first character. I want to take the address of the first character. That's the left pointer. Now, then I will define another pointer called the right pointer, which is going to be the last character in the string. Now, the last character in the string is the final, the one that is I'm going to consider that as the null character. So I'm just going to say it's going to be S plus the length of the string. Now, because I don't have a length function in this library, I'm just going to include string.edge. So I can use its length function. So I'm just going to say S plus str len of S. So in this case, what I did was I took the address of the first character, add the string length to it. So just by looking at one of the examples, so let's say we're looking at Ruth. We have a pointer to this, and this is the null character, that's the last character. Okay. So at this point, the length of the string is 4. So if I go from this point to +1, +2, +3, +4 would point me to the null character. So in this case, the string length would be, in this example, the string length would be 4, and therefore it's pointing to the last one. All right, so what we're going to do is we're going to write the loop for I equals 0, and let's call it string length, this is from the standard library. plus, oops, I plus plus, and here's my loop body. And what I need to do is to have a temporary variable inside. Although at this point I have to make a design decision. The question is whether my temp variable would be char star or just a char. I will argue that it should be a char because you must save the character before you can overwrite that with the pointer. So I'm just going to say temp for that, and the temp is going to be the character at the left pointer, which should be the this character R. Okay, and then I'm just going to say star left pointer would be assigned star right pointer. But that would be incorrect because star right pointer would be the null character. So it is going to overwrite the R with the null character. That's not what you need. You need this character. So this means you have to take the right pointer and subtract 1 from it. So it will point to here. All right. So what I'm going to do here is just subtract. So right pointer minus minus. So I should subtract 1 from the right pointer and point to H. And then I'm going to say left pointer is assigned the right pointer. Now after I do that, I'm going to increment left pointer by 1. Now keep in mind that I'm not being too careful with the code structure here. I'm just trying to get the logic done correctly. So you may want to reorganize this kind of a code. And then what I need to do is I will take the left pointer here, and before I increment it, we'll have to try to do right pointer is R pointer is assigned the temp, and then I'll increment the left pointer and I decrement the right pointer to go to the next one. So that's pretty much my code. And let's save it, and let me just go ahead and compile that. Okay, right now it's called string P because I'm using the pointer notation. I'm going to use the same demo to test it. Oops, I have a warning here. String reverse, so it's okay. Obviously, I didn't. So I need to go back to the code string P. And I did the reverse, but I didn't return anything. I forgot to return S. Return S. And S is the pointer to the first character of the reverse string. All right, let's try that again. Okay, that sounded good. Then we'll go to Emacs and escape X, type GDB. Okay, so let's enter the GDB Emacs debugging environment. So I'm just going to press enter here. So I'm in the GDB. I'm just going to put a breakpoint string reverse. All right, that's good. And then I'm just going to say run. So now the program got started. It's in the function string reverse, and it stopped. It's running now. It's in the statement test. I printed it out, and it's passed this, and it passed the AC source into the function because it has entered the function already. So at this point, if you type print s, you should see root, which is good. And so let's do the next one. So it's doing that line. So if you say print, so let's print the LPTR. So it shows LPTR is the f of 0, which is this address here, which is the same as the address of the first character of the string. Now, if I say next, so it must have computed the RPTR. So let's take a look at the RPTR. That's interesting because it says RPTR is going to be f of 4. And that makes sense because if this is 0
and that's 1, that's 2, that's 3, and that null character is the 4. So RPTR is pointing to the null character. Remember we added S, which is the address of the first character, to the string length of S. In this case, it would be 4. So that sounds good. And then I'm going to press next, expand this window a little bit. Next, so I must be going through the first iteration of the loop. Okay. All right, so I'm going through that. Okay, I finished the first iteration of the loop, and I is still 0, but if I print S at this point, because I changed the S using this L pointer and R pointer. So if you print S, you will notice that the H and the R are exchanged. So if I go next, 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 it's my second iteration. So if I print I, I'm going to see I equals 1. And if I print S, I'm going to see that U and T are now exchanged. It's T and U. So this is really what I need, right? Root is reversed. So now this is the correct string. So I want to stop and pass the string back to the main program. So if I say next, it seems like it's going through another iteration. Okay, so maybe I have to fix my logic. So if you look at print I is 2. That's because, I went to string length S. I should have gone to string length over 2. So technically, I should have stopped after the 2 iterations, after I equals 1, because I got the string reverse. And so you get the idea. This is just a simple example of how you would do a pointer implementation. So it's not, notice in this case, I'm using pointer to traverse. I'm going plus plus, minus minus, and so on. So when you're doing your assignments, you want to try to use bracket notation for the arrays and the pointer notation for the pointer implementation.